Bismillahirrahmanirrahim. Welcome to MIT. Today we are going to solve a question from mechanics. And the question belongs to paper 9709/42 for the session October November 2024. And we are going to solve question number 7. Let's see question number 7. This is question number 7, which is two particles A and B of masses zero point 0.2 kg and zero point 0.3 kg respectively are connected to the ends of a light inextensible string. The string passes over a small fixed smooth pulley which is attached to the bottom of the rough plane inclined at an angle theta to the horizontal where sin theta is equal to 6.6. Particle A lies on the plane and particle B hangs vertically below the pulley 0.25 meter above horizontal ground. The string between A and the pulley is parallel to a line of greatest slope of the plane. See the diagram. The coefficient of friction between A and the plane is 1.125. Particle A is released from rest. Question number A says, find the tension in the string and the magnitude of the acceleration of the particles. So this is not a very new question in Cambridge curriculum. We are very well acquainted with such question and we are going to solve this. Before we start the solution, we should pick up the concept. If we fail to find out or pick up the right concept, then we will get confused at one stage. So the concept we should apply here is the concept of motion law of Newton. Motion law of Newton will be applied for finding the missing string as well as acceleration of the particles. You can see I have already solved this. I have written over here. Now I am going to explain how I did this. Let's start. We have already decided that we will have to apply the concept of motion law of Newton. Now we will see what are the information given over here. Look, the plane on which particle A is sliding down or is placed is rough and B is just 1.25 meter above the ground. Well, and the coefficient of friction between A and the plane is 1.125. This is actually mu. And the other information is that sin theta is 0.26. And we will have to solve these question forming two equations as there are two values missing. One is tension, the other one is acceleration. So we will have to form two simultaneous equations and they will have to be solved simultaneously. And before we solve the main part, we should solve one of the parts, which is frictional force. Look at this. About particle B there is no question, it's just hanging downward, but for the surface AB, means upper part, means the plane which is rough means whenever the word rough surface is mentioned, we know we will have to find the frictional force. So first of all we will find the frictional force acting on this. So what we will do is finding frictional force. Once again I am repeating, whenever a rough surface is mentioned or rough plane is mentioned, then first of all we will find the frictional force. So I have drawn a figure over here. You can have a look at this. Here A is lying on the plane. This is the plane and A is, the question is find the tension in the string and the magnitude of the acceleration of the particles. Well, whenever A is released, A will slide down this way. This is the plane. A will keep on sliding down. And what are the forces acting on this? Actually, one force is the tension, which is moving it downward. Another force acting on it is the weight. Weight is mg. So we will resolve these two forces, component of these two forces. So frictional force of A, we know the frictional force is denoted as Fr, and frictional force is equal to mu r. Okay, frictional force, or this is, you can call it normal reaction force also. So mu r, sorry, not normal reaction force. Fr is frictional force or resistance force, whatever you tell. Because here frictional force is the resistance force, only resistance force. So mu is our frictional coefficient, and r is normal reaction force. Normal reaction force is this vertical line, which is normal means always it is vertical to the horizontal. Okay, so we have written the value of mu is 1.125 into that, this normal reaction force. Normal reaction force is acting as vertically upward, and normal reaction force is always termed as mg cos theta, weight cos theta into weight. Now you may ask a question that why should it be cos theta, why not sin theta? Because this is vertical. Look in term of this figure, this is, here is the angle. Okay, and normal reaction force acts vertically upward. So this, in terms of this triangle, this is horizontal sides, I mean adjacent side of the triangle. So for adjacent side of the triangle, we always use cos theta. Okay, so mg cos theta, 1 point, then 1.125 into mass of the particle is zero point 0.2. We can see from here it is written, this is 0.2, you can see over here, this is 0.2. Then G, acceleration due to gravity is, we know, 10. Cos theta is equal to zero point 0.8. Now zero point 0.8 is not given actually. Let us see the sine theta. It is given sine theta is 0 0.6. So if sine theta is 0 0.6, sine theta is the ratio of vertical line over hypotenuse. I have shown here through a figure. Look at this. It is actually zero point 0.6 sine theta. If this is theta, okay, this is our angle, and they told that sine theta is equal to 6. So sine theta means actually sine theta. Sine theta is equal to this perpendicular line over hypotenuse, means zero point 0.6. And we know cos theta is equal to, if this is 6 and this one is 10, definitely the adjacent side will be 8. How? This is actually 6 square means 10 square. 10 square minus 6 square is equal to actually 8 square. 10 square means 100. 100 minus 36 is equal to 64. Means this is Pythagorean theorem. So we using or applying Pythagorean theorem, we have got that cos theta is equal to 10 over, that means adjacent over hypotenuse. Hypotenuse is 10. So ultimately our cos theta is 0 point 0.8. For further clarification, if I get time, I will clarify once again. So what have we learned? That cos theta is equal to 0 point 0.8. Let me erase this unnecessary parts. So after simplification, we have got that it's 1.8. This is our frictional force. Well, now for A, we have already decided there will be two equations, one for particle A and another one is for particle B. We have started with particle A. Let's form the equation applying the concept of motion law of Newton. We all are acquainted with this equation, that is driving force minus resistance force equal to ma. Now we are going to decide what is the driving force. If we analyze the figure of A, we will see that, look at this, here A is moving downward. A is moving downward, I mean sliding downward. So what is the driving force here? It is connected with, A is connected with the string. So the tension is actually causing it downward. So this is driving force. Tension is driving force. And another driving force is our weight. Weight is also a force which is acting as driving force. Weight is causing it moving, sliding downward. So two driving force have been obtained or found for particle A. So we have written that these two driving force, one is tension, the other one is weight caused by force caused by weight. Now you may ask a question: how can it be the driving? I mean mg sin theta. So just simply you can remember, for frictional force or resistance force we have used mg cos theta, which is actually normal reaction force. Normal reaction force is always alternative or opposite to driving force. So if reaction force or resistance force is mg cos theta, definitely your driving force will be mg sin theta. Sin theta and cos theta, they are opposite to each other or vice versa. So these two are our driving force. Once again I am repeating. So for A there are two driving forces. One is the tension which is causing moving it downward, and another one is weight which is also sliding it downward, that means causing the particle sliding down. So these two are the driving forces. Now we will write these two. These two are our driving forces, and I have already clarified that how can mg sin theta, mg cos, if mg cos theta is the normal reaction force or resistance force, then mg sin theta will be the driving force. Okay, then resistance force we have already decided for particle A. This is particle A. There is no other resistance force except the frictional force, except because the plane is rough, not smooth. So there is only one resistance force, which is frictional force, and we have already obtained the frictional force is mu r. Mu r has already been obtained. We have done it prior to the main solution. Then equal to mass into acceleration. After that we have written here t, and m is zero point 0.2 g. Acceleration due to gravity is 10, and sin theta is zero point 0.6, which is already given. I have shown and explained. This is our sin theta. Yes, this is sin theta is equal to zero point 0.6. So we have just substituted the value. After that after that, here minus 1.8. 1.8 is the frictional force we have already obtained. Equal to, right side is mass is zero point 0.2 and acceleration. Now if we isolate A, then all of them will, this zero point 0.2 will go down. This zero point 0.2 has gone down as denominator, and all of these are as numerator. Okay, so it is t, and if you simplify it is going to be 1.2 minus 1.8. So our acceleration a is equal to t plus 1.2 minus 1.8. If we subtract 1.2 from 1.8, it is going to be negative 0.6. So our a is actually, I have written just beside this, our a is going to be t minus 0.6, t minus zero point 0.6 over zero point 0.2. This is our equation number 1. We have formed, apply, resolving all of the forces acting on particle A. Now for particle B, just have a look at particle B. Particle B is just hanging downward. Look, this is the state of particle B. Okay, B is over here, and this is uh, just hanging downward. So what is the driving force for this? As this is hanging downward, nothing but the weight is causing it moving downward. So only weight is the only force acting on this as driving force. And what will be the negative force? What is causing resistance to this motion? Actually nothing but the tension, because there is a tension acting between A and B. So driving force for B is weight, and resistance force for B is nothing but the tension. So don't get confused with the frictional force. For B there is nothing as frictional force, because B is not at all any rough surface, it is just hanging. So once again I am repeating, for B our driving force is, I have written over here that the same concept, driving force minus resistance force is equal to MA. So driving force is, we have already decided, it's nothing but mg, weight. Only weight is pulling it downward, and resistance force is also nothing but the tension. There is no question of frictional force for particle B, because particle B is not in contact with any surface at all. Now you may ask a question that in the previous case we have written for weight, we have written mg cos theta or mg sin theta. Now why isn't it? Actually this is just vertically downward, okay, moving downward. So here if you use mg sin theta, I mean, sorry, mg cos theta, then it will be cos 0 degree, cos 0 is equal to 1, so it is mg, simply mg. If I get time at the end I will clarify it once again. So weight is mg and frictional force is tension. Then mass of the particle B is zero point 0.3 and acceleration due to gravity is 10, minus tension is equal to 0.3, that is mass. After that, simplify if we simplify, it will be zero point 0.3 into 10 is actually 3 minus tension, and this 3 has been, this zero point 0.3 has been written as denominator. So our acceleration is equal to 3 minus t over zero point 0.3. Now this is our equation number 2. We can see equation 1 also. This is equation 1, whereas this is equation 2, as both of them is actually acceleration and they are connected with each other through a tension force. So definitely acceleration in both cases will also be equal. So what will we solve? We will just form these two equations as simultaneous format. So t minus zero point 0.6 over zero point 0.2 must be equal to 3 minus t over zero point 0.3. Just I have written over here from equation 1 and 2. 3 minus t over zero point 0.3 is equal to t minus zero point 0.6 over zero point 0.2. Now if we do cross multiplication, it is going to be 0.6 minus 0.2 and 0.3t minus 0.18. Then if these two tensions are added, because if it is moved to the left side it will be negative, so 0.5t equal to, if we add this zero point 0.6 and 0.18, it will be 0.78. So our t is equal to, both of the sides are having negative symbol, that can be omitted. So 0.78, it is t is equal to 0.78 over zero point 0.5, if this 5 is transposed to the right side. So ultimately we have got that our tension is 1.56 Newton. And it's not only tension what we should found, they told there is one more value should be obtained, it is tension as well as acceleration. Okay, so we have already formed the equations using acceleration in 1 and 2, so we can use this one. Look, this is the, this is one equation and another one is this, so any of the equation can be used, both of them will produce the same value. So our a is equal to 3 minus 1.56 over zero point 0.3, and ultimately we have got that 4.8 meter per second is our acceleration. So these two are our answers. This one is the tension and this one is our acceleration, and we have done the solution. For just have a look, I am showing it the whole solution together so that you can copy this. This is the whole solution at a glance. Well, let's move on to the immediate next question. The question number B says, this is B. B says when B reaches the ground, it comes to rest. So B came to rest after reaching the ground. Find the total distance that A travels down the plane from when it is released until it comes to rest. You may assume that A does not reach the pulley. So let's analyze the question again. Let's go back to the question. This is our question. Okay, if they told when B reaches the ground, look, this is the ground. Okay, when B reaches the ground, B must travel this distance, isn't it? So 0.25 meter for reaching B, for B to reach the ground, 0.25 meter distance has been covered. So if B travels 0.25 meter, definitely A will also travel 0.25 meter distance. So one thing is very sure, that when B reaches the ground, A has traveled 0.25 meter distance. That is done for each of them. But when B reaches the ground, then B is no more in motion. B is just in contact. It is written here that not in question A. Question B says, yes, here it is written that whenever B, you may assume that A doesn't reach the pulley, and when B reaches the ground, it comes to rest. So state of B is in no motion, it's on rest. So whenever B reaches the ground, then there is nothing related to B. B is over. Okay, so whenever we calculate this 0.25 meter distance, because they told us to find the total distance. So first distance, there are two phases actually. For first phase is A and B, both of each of them has covered the equal distance, that is 0.25. Then for the second phase, only A will move down, A will slide down due to the weight or some other forces, due to external forces, not external forces, due to another forces, but B will be at rest. So first phase has already been completed, that both of the each of them has covered 0.25 meter, and we are supposed to find actually how much is the distance traveled by A in the second phase. That means when B is at rest. So let's start our solution. Well, before solving the major part of the solution, we will have to find out, pick up the concept we are going to apply. Look, here they have told us to find the distance. Okay, to find the distance A travels down the plane from when it is released until it comes to rest. That means it is all about distance, means S. Okay, and what are the information we can extract from the given scenario? They may be acceleration. We can get acceleration, velocity, that means initial and final velocity. So ultimately, as there is nothing related to time, so we should not opt for the formula which contains t. So avoiding t, the formula, the concept for Shubert concept, which is called Shubert concept. Among Shubert concepts, there are many formulae. Out of those, we are avoiding t is not necessary in this case, so we will not include t. Except t, the other formula is actually v square is equal to u square plus 2as. Okay, so we can easily extract a acceleration. Displacement is to be obtained, and initial and final velocity, that is also somewhat known to us, or we can just analyze this one, because initially both the particles were at rest. So and final velocity can be obtained, initial was 0. That means we will have to decide that we are going to apply Shubert formula, and among Shubert formulae, t is not involved here at all, time is not involved. That's why except t, there lies only this formula, which includes final initial velocity as well as acceleration and distance. So we have decided we are going to apply this. Now one by one we will find out our required information. First one is we should know that acceleration. Okay, so I have written here, before I start writing, showing the solution, just let me show you the graph. So this is what the graph is actually. Look, this is the state of A has been released, top point from here. Then when b reaches the ground. Yes, this is the ground. Okay, when b reaches over here, then this distance is 0.25 meter. So the same distance, equivalent distance, was traveled by a also. So this distance is 0.25. Already we have got one distance. They told until it comes to rest. Okay, when there was a string was like this, but whenever b touches the ground, then string is not taut anymore, this is slack. At one stage a stops moving downward. Okay, so at this point for a, this is actually rest. For a, this is rest position, it's not in motion or instantaneous rest, whatever you tell, it is instantaneous rest for a. And b is no more included. Now we will see what is the, we require the acceleration, am I correct? So for acceleration we can use or reuse this information. Look, when b touches the ground, then b's final velocity is 0. When b's final velocity is 0, we should know the final velocity of a. uh, Final velocity is 0, but sorry, initial velocity was 0, final velocity is not 0, because just the moment before b touches the ground, we will come to know the final velocity. Final velocity for b will be the initial velocity of a at this point. Okay, so let's find the final velocity for b. When for a, when b reaches the ground, because a is also involved, don't get confused. A and b, both of them, as both of them are moving down together, connected with each other, so the same acceleration, same velocity, final velocity will be applicable. So we have written the same concept, motion law of Newton, driving force minus resistance force, and driving force for b is nothing. We have already shown that b is, nobody is pulling it downward, b itself due to the weight is coming down. So the driving force for b is nothing, just weight, which is mg sine theta. Then frictional force is mu r. Okay, this is this is for a, sorry, we are finding it for a, not for b. I told it wrong. For a, so for a, driving force is in the previous question, so we have solved driving force, it's exactly same. Let me show you. It was for a, look at this. For a, this is driving force minus resistance force is equal to ma. Ultimately we have got that acceleration is, this was the acceleration, this was the acceleration, but for this acceleration both of them were connected with each other. Now what is left, actually we will just avoid the tension, there is no more tension. We should not forget that when b reaches the ground, then there is no tension or other forces at all, only these two forces are acting on that. One is weight minus resistance force, that's why we have written only the force of weight minus frictional force equal to mass into acceleration. So tension is no more effective because b is already on the ground and no more force is in between the two particles through the tension. So what will it be, mg sin theta minus mu r, and we have already obtained mu r is 1.8. We are going to just substitute these values. This is mg sin theta, you can see this is mg sin theta minus mu r equal to mass into acceleration, just we have avoided tension. So mg sin theta, we have explained that it is going to be 1.2, and 1.8 is the frictional force equal to zero point 0.2a. If 2 is taken at the bottom, then this will be on top. Okay, so acceleration is equal to, it's a different acceleration, acceleration is equal to -3. So this is for a, which the acceleration through which it is sliding down after b reaches the ground. Now we will find the velocity of we have already decided we are going to apply the Subert formula. So for Subert formula, we have got the acceleration. Now we will find the velocity. First, let us find the velocity from each of the particle will be can be found, but we have chosen B because this is easier to be obtained. So we have written V square is equal to, this is the concept, V square is equal to U square plus 2AS, and V is equal, this is for B, look, not for A. This is actually about B. We are talking about B, the final velocity just before it reaches the ground, because both these velocity will be applicable for both A and B. So we are writing over here that v square u square initial velocity, both the particles were released from rest, so initial velocity is 0 to A is 4.8. So don't get confused, this A is when B reaches the ground, when there is no tension at all. So this is acceleration only for applicable for A, not for B. We are searching for B. For B, acceleration was 4.8 in the previous page, on the previous page. Yes, this was our acceleration. Acceleration was 4.8 for A and B combined acceleration. But here we are, okay, it's all about B. That's why the combined acceleration has been applied. Ultimately, we have got the velocity of B. Velocity of B is point square root over 2.4. So this velocity is, this is the final velocity for B. I have already explained. Look, final velocity of B, this is final velocity of B must be the initial velocity of A at this point, because it is, this is the second phase for A. So here the velocity is square root over 2.4. Now this is initial because A is moving, sliding downward. Okay, then let's write, we are going to write initial velocity. I have explained in words also. Initial velocity of A when B reaches the ground is equal to point square root over 2.4. I have already shown. Again I am showing for the last time. Look, the final velocity for the first phase, final stage is this for first phase. At the same time, for the second phase, this is the initial phase. So initial velocity for A is square root over 2.4. So the same concept, Subert formula, v square is equal to u square plus 2as, and final velocity is actually 0 when, because the once again initial velocity was this square root over 2.4, but final velocity y is 0. I can show you. Look at this. It is written when it is released, I mean A, until it comes to rest. So the particle has come to rest at one stage, at final stage. That's why final velocity is 0. Final velocity is 0. Initial velocity we have already got 2.2 square root over 2.4 square minus 2. Why is there negative symbol? Because actually these three, acceleration for A, this is only for A. Look at this, acceleration of A for the second phase is negative 3. So we have used here negative 3, negative 3, this negative 3. So 2 into negative 3 into s is to be obtained. Okay, so we have written, if we simplify, this is 6x, and if it is, let me show you more clearly. Yes, if this is 6s, so 6s is equal to, if this is taken to the other side, square and square root, they can dissolve each other, it's 2.4. Then s is equal to actually our zero point 0.4. So this is the distance traveled by A in the second phase. Already both of them has, each of them has traveled this distance. This distance was common for each of them. This one combinedly, each of them traveled this distance in the first phase, and in the second phase only for A it has traveled zero point 0.4 meters. Now total from here to here, this distance is to be added. If we add up 0.25 plus zero point 0.4, it will be 0.65. Yes, total distance for A is 0.25 the first phase, zero point 0.4 is the second phase. So total 0.65 is a total distance. Now I can show you the whole of the page for a look. This is whole of the solution of B. So now for the last moment, if you ask me to explain, it is actually, first of all, they have told us to find the distance. For distance, we apply the Shubert formula. For Shubert formula, as time is not involved, look, this should be decided first of all before you start for the solution. Otherwise you will get confused at the middle of the solution. So at the very beginning, we have decided we will apply the concept of Shubert formula. For Shubert formula, as time is not involved at all in the whole system, that's why we have avoided t. Except t, the other formula including velocity and acceleration is v square is equal to u square plus 2as. So we have chosen this formula for each of the particle. Then there are two acceleration. One acceleration was when both of the particles were connected with each other, and the second phase is B has gone away, only A was in motion for a while. So there are two acceleration. One acceleration is this one, -3, this is only for A, and another acceleration was 4.8, which was combined acceleration for each of them. We have picked it up from the previous question. Then we have got two distances. One distance is very simple. When B reaches the ground, the distance was 0.25 meter. And the second one we have obtained analyzing this equation. And for A, if we go back for A was about to find two missing information. One is string as well as acceleration. So for this, always we form two simultaneous equation and they are solved simultaneously. And the most known concept, most widely applied concept is the Newton's motion law. We have applied the Newton's motion law, that is driving force minus resistance force. This is the basic formula. Driving force minus resistance force is equal to mass into acceleration. And for driving force and resistance force, there is a little variation, because for a driving force there are two driving forces. One is tension, the other one is mg, that means weight. But for B, it is nothing but weight, which is pulling it downward. And for frictional force also, frictional force is applicable only for A, because it is sliding down a rough plane, whereas B has nothing in contact. So that's all about the both of the solutions. If my efforts come to use to you in the least bit, then it will be a great pleasure for me. I will be thankful to Almighty Allah. And if you really get benefits through this discussion, then I request you to pray to Almighty Allah for my betterment in the future. Fi amanillah.